Yeah. So, good evening, everyone. Thanks for joining in. So, first of all, let's figure out this. Is my audio properly clear? Is everyone properly can hear it?
Yes. Yeah,
Yeah.
yeah.
Yes, yes.
Okay. So that's good then. So let's move on. I think we have spent some 5 minutes. Now we can just move on. So first of all, thanks for joining in once again. So I'm by the form entries, I'm understanding that most of the students are from first and second years. Is it so? Can you just tell me how many of you are from first and second years?
I am from first year, second semester.
Okay, okay,
I'm also from first year, second semester.
I'm
I'm
also
okay.
from
also from
first year.
first year, second year semester.
Yeah, yeah. Cool, cool. I got it. I got it. Yeah. So basically, the thing is that the things that I'm going to speak today, some things you may know, while most of the things you may not know. So don't worry about that. I will try to go down as much as possible within this time frame. But the main thing is that I want you all to get introduced to all the kinds of tools that we are doing in our industry right now. Okay. So the main motto is to educate you about the processes and the tools that we are using. And once you get over this kind of understand this kind of tools, then you will slowly in your further years you will understand how to use them. Okay, so take this as a stepping stone, and if you're not understanding anything, don't worry, you will get it soon afterwards. Okay, so mostly, as I know that mostly in our college, most of the students from the first and second years like to mostly try to develop something, like mostly try to either be a web developer or try to be an Android developer. So mostly they like a development. I was also one of them, and I also have seen a lot of people, students basically, who try to enter in the field of development using web applications. So in this session, my main objective is to show you how you can deploy web applications on Kubernetes using continuous integration with Circle CI. So I think web application part, I think everybody can understand what do you mean by web application. So just can just say if you can understand what is web application. Yeah, is web application, what do you mean by web application is clear to everyone? Then we can move on then.
Web application is maybe something which runs on a server or a website, maybe.
Yeah, basically is that basically whatever applications you can interact with inside your browsers are all web applications. So it may be a website like amazon.com, maybe website like spotify.com, anywhere, any of these websites which you can run inside a web browser are web applications. But nowadays also you can run web applications inside some native desktop browsers also, with the help of some of the React Native tools, and also some, I think, some desktop versions of this web browsers also available. But the main objective of this session is to show you how to deploy this kind of web applications on Kubernetes. So the term Kubernetes, it's a very complex term. If I speak frankly, then the term Kubernetes, it's something like people go for certifications to understand Kubernetes. But after spending 2 years of understanding these Kubernetes, as well as working in the best company in the world whose basic main product is around Kubernetes, I've understood that the developers can actually leverage the power of Kubernetes without actually knowing what's happening inside Kubernetes. Okay, so Kubernetes is something that comes with a lot of tools and techniques and everything, but as a developer, you can leverage all those features of Kubernetes without even knowing what is happening behind. So in this session, I'm going to present you a developer perspective of how to use Kubernetes. Okay, so let's proceed. So who am I? So I am Avik. I'm currently a software engineer at Red Hat, and also I am a beta Microsoft ambassador, and also currently I am the Mozilla Club BBSL co-lead. So apart from that, I like to talk about open source, and as you can see, I like to speak on some technologies, and mostly I like to contribute to different kind of CNCF projects. Okay, so that's about me. So you can visit my website or any other links and get in contact with me. So moving on, next slide is what is the overview of this session. So let's understand what are the things we are going to touch upon. So first, the introduction part, which is already done. Next, we are going to understand what do you mean by containers, following by Kubernetes Continuous Integration, then discussion on Azure and Circle CI, moving to the infrastructure design, and finally the hands-on. So it's going to be a 1 to 1.5 hour session. And if you have any doubts, just you can just unmute and speak out. Okay. So moving on, let's start then. So first of all, let's understand what is the relation between infrastructure, data, and applications. Okay. So I'm taking a scenario from early 2000s till 2020. Okay. So previously, when you see in this picture, you can see like in early 2000s, the infrastructure size was very big compared to the data and application size. That means at that time, the cost of setting up infrastructures and also the size of infrastructures were very big. For example, you can just correlate the fact that if you have seen a floppy disk is so big, it's like a rectangle, it's like a phone, size of a phone, but it stores only 3.5 MB or 4.5 MB of storage. So you can understand in the early 2000s, at that time, the storage technologies were not that advanced. So the infrastructure or the place where data can be stored had to be very big. Okay, so a lot of investments were required to set up those infrastructures. And at that time, the data was very less. As you can understand, internet was just booming at that time, so data was not there so much. And the application size were medium. Fast forward, we see in 2010. So at that time, we see the infrastructure size getting smaller, while the size of data getting bigger, while the application size getting much bigger. So what do we infer from this? We infer that in 2010, in the last decade, there was series of improvements in the infrastructure where more complicated or more storage efficient devices were launched that helped to reduce the size of the infrastructure. And also, as internet was booming, data increased, and also we also saw the launch of various very intuitive applications on web. For example, in 2010s, you could see a lot of dynamic web applications. It may be Amazon, a lot of startups, a lot of the future of Fortune 500 companies we know now mostly tried to actually play the part in the 2010 area. So you can see the application size also increased. Fast forward in 2020, we see the infrastructure size has gone way smaller, data has gone very big, as well as the application. So from this chart, we can understand that the trend is that the infrastructure size has been shifting to the decreasing approach while the data is increasing. So this is very important. Just keep this in mind. Moving on. Now let's see the evolution of the application development processes. So first of all, in the traditional time, when actually this kind of software engineering was booming, so people once followed a model known as the Waterfall Model. So it's a basically simple model where first of all, you understand what is to be developed, then you design that thing, then you build that thing, then you test, and then you maintain that thing in stepwise order, like a waterfall. Okay, simple thing. But later it was understood that this kind of process is not suitable for some big organizations, because when you are running a big organization and you have multiple fundings and there are many investors and customers looking for your product, you have to deliver them fast. You just can't wait for all these steps like the testing, development, and all these steps to take place one after the another, and then then produce the product in front of the customers. You have to develop very fast. So for that, the agile development was introduced. So in this agile development, what happened? Basically, every development is happening in sprint. That means in 14 days time, we make a small part of that product and deliver that product in front of the customer, so that the customer always can see the part of the product in front of them whenever they want. They don't have to wait till the entire product gets built. Okay, that's one of the shift that we saw. Apart from that, the latest shift that we see is the DevOps shift. So what do you mean by DevOps? So basically, when you're working in an organization, you will find a team called developer team, while there will be another team that are the operations team. So the developer develops applications and then transfers those application to the operations team, while the operation team works on that and basically deploys them in all the servers or maintains them, does all this work. Okay. So now, according to the concept of DevOps, we are trying to merge, or we are trying to reduce the gap between the developers and the operations. Because a lot of time we saw that developers had pushed their code while the operation team were not free. That led to the delay of the launch of the product. So we don't want that kind of problem anymore. So we are trying to reduce the gap between developers and operations. So that's why the concept of DevOps arose. So with the help of various tools and techniques, the things also what we are going to run in this session, we can understand how we are able to reduce this gap. So moving on to the next part, that is the application architecture evolution. So mostly previously you can say, or whatever development you do right now. So if you're in a first and second years, the first project, if you have started, then you must have actually placed all your code inside a single repository. Like suppose you are making a small web application, you must have placed your front end as well as the back end together in a small single repository, and you are trying to deploy it. Okay, so that kind of approach is known as a monolithic approach. That means your front end and the back end as well as everything is in a single code base. While in the recent times, we see a shift in this also. So what is the shift? The shift is the movement towards a microservice architecture. So in a microservice architecture, we see that we don't maintain a single big code base. We divide that code base into multiple smaller parts and deploy or host these smaller parts in different areas. For example, suppose you are making a web application and you are trying to follow microservice architecture, then you will place your front-end code in a separate repository, while your back-end code in a separate repository, and you will deploy this separately, and then they will communicate each other with the help of APIs. Okay, so this kind of architecture or development process is the microservices architecture. Okay, till now I think it's clear. If you have any doubts, you can just unmute yourself and speak. Okay, so moving on, what's the evolution we saw in the deployment and packaging? Now this is very important. So previously, you can see mostly previously we used to follow, or we used to have a physical servers hosting all our data. So basically you may consider like bringing a big server and setting up at your home and installing your web application in that server. Okay, so after that it was understood that a single server, and you can install some applications, but suppose you want a different kind of environment to run another application, you can't do that. So for that, basically the concept of virtualization key. So I think if you are studying in kit, and if you have got the kit laptop, you must have seen a software known as VirtualBox there. So the VirtualBox actually is a virtualization software. So what does it do? Basically, through VirtualBox, you can actually run multiple operating systems in your own computer. And on those operating systems, you can install your applications. So you see, a single computer can be used to deploy various applications running in various operating systems. So this was not possible in the physical server's time. But now, even later, we see more shift towards a container-based architecture. So what are these containers? Containers, to be very simple, basically you take the code and you place all the dependency required for that code in a small box, and that box is known as a container. So you have a code, like you have a code for your website, and you have all the packages that requires to run that code. You put them together in a box that becomes a container. Now, what's the difference between container and virtual machines? We're going to see soon. After that, let's see the evolution of the application infrastructure. So previously we had data centers, big data centers in our homes also. Sometimes if you see some older companies or some older companies that had started in 1990s, they used to have data centers in their own offices. But this changed soon. On the advent of cloud technologies, we saw that people tried to deploy their applications on cloud. What was the benefit? Benefit was that they don't have to buy or invest on devices or in technologies. They could just rent it from the cloud. Suppose I want a CPU for a particular day because I have an event on that day. Why do I need to buy a new CPU for that, or can I just rent it at a cheaper cost? So obviously people try to invest more on renting stuff rather than buying stuff. That's why this cloud technology is boomed in this century, in this decade, I mean. Okay, so I think you have got this, whatever this slide is trying to say. Moving on, now let's understand what is the difference between a virtual machine and a container. This is important because virtual machines are a decade older thing. Now we have moved to the containers. So we need to understand what's the benefit of using that. So in this case, you can see like we are trying to actually install a database in a virtual machine as well as in a container. Databases, I'm sure you must know what is databases. Basically, MySQL, MongoDB, anything, these are called databases. So suppose you want to install a database in a virtual machine. So what do you mean by virtual machines? So if you know about AWS, and if you have used AWS, you must have used something known as EC2 or the Elastic Compute Cloud. Or if you have used Azure, then you must have seen virtual machines. So those are basically VMs. So if you want to install a database in a VM, then you have to follow all these steps. First of all, you have to provision a VM, then install the OS, then packages, provision volumes, install the database, configure it, and then test it. So many steps, and all of them have to be done mostly manually. As you know that you have to go to your AWS site and then select which of the operating system you want, what is the size of the RAM you want, and all those things. So it's a more manual job. But if you are trying to deploy a database or install a database in a container, that also with Kubernetes, you can see with a single line of code like kubectl create file name mydb.yml, I will be able to create that database. I don't have to provision anything, nothing else. This Kubernetes will handle everything. So I think now you're going to understand, you're understanding like from what do you mean by containers, because this is very important. As a first and second year student, I don't think you may know what is container, but now I think you must have got an idea of what do you mean by containers. So what are the benefits of containers? We are understanding. Yeah.
Docker
Yeah.
is Docker and Kubernetes similar?
I'm coming. Docker and Kubernetes are different things, but there is a connection between them, but it is not the same thing. Okay, I will come there. Okay, moving on. This slide basically again explains the difference in architecture between a virtual machine and a container. So you may be a little overwhelmed by seeing this diagram, but it's not that hard. I'm telling you how to see this diagram. So basically at the lower part, you can see something that has infrastructure in both the places. So infrastructure you may consider to be your computer. Okay, it is your computer. So on top of your computer, you have your operating system. So mostly it's Windows. Okay. Now, if you are using a virtual machine stack, or if you are trying to use virtualization, that is mostly done in all those cloud services in EC2 or in virtual machines, or even if you have VirtualBox in your computer. So how does it function? So this is your operating system, that is Windows. On top of that, a hypervisor is installed, and on top of hypervisor, you install multiple guest operating systems. So basically you can understand that VirtualBox, the Oracle VirtualBox that you have in your computer, helps you to create this hypervisor so that on top of this, you can install your guest operating systems. And on those guest operating systems, you are installing your applications. Okay. But if you see the picture of the containers, in containers, you see you have your computer, you have your operating system, but on top of that, you can directly install your containers. You don't need any hypervisor, you don't need any guest OS, nothing. You just install your containers that will have your application. So you have a more lesser overhead. Your containers are more lighter, more portable, and more smaller than virtual machines. In fact, if you try to launch a virtual machine, it will take normally 30 to 35 minutes, if you normally try to launch a virtual machine. But in containers, it takes less than 10 seconds. It's so fast because there is less overhead, and in a container, you place only the stuff that is required to run that application, nothing else. No more jargons, nothing else. Okay. So I think you have understood, the meaning of containers. So the question that you were asking about Docker. So basically, to make this container, Docker is a tool that helps us to make containers. Okay. So Docker helps us to make containers, but Kubernetes uses Docker to make containers. So you may understand, like, there is containers at the end. On top of that, you have Docker, and on top of Docker, you have Kubernetes. It's like this. Okay. So moving on. Yeah. So I think this part you have understood. Like in monolithic application, first of all, let's visualize a concept of a e-commerce website like Amazon. Okay. There is a website of Amazon. So Amazon website has multiple things. It has a front end, it has an account service, it has a payment service, and it has a shipping service. Like when you just see your account, the account services gets launched. When you try to make payments, the payment services get launched. And when you try to put your address and shipping details, the shipping services get launched. When you're using a monolithic kind of application, all this code are placed in a single repository. Okay, everything in a single repository you're placing it. But when you're talking about a microservice-based approach, then you see front end, application service, account service, payment service, shipping service are all separated. They are separated and hosted in different areas, but they can communicate with each other with the help of APIs. Now let's understand what is the relation between microservice and a container. So till now you have understood what is the benefit of containers. So containers basically help us to package our code as well as the dependency together in a single box, so that whenever we deploy that box anywhere, it can start to play. Basically, it's a plug and play solution. You don't have to install anything else. Okay. So it was understood that if you're trying to use a microservice-based application, at that time, if you can containerize each of these services, it becomes more easier for you to handle. For example, suppose you have separated the front end part out of the entire code base, and now you make a container, like you place the front end inside a container and then place it somewhere. It becomes more portable, more easier to handle. Similar to the case of all the other services also. So rather than just separating the code and deploying it in a repository, making a container out of that part of code and deploying that container as a whole gives a more better architecture. Okay, it's more suitable and more preferred. You're getting it, right? So till now, any more questions if you have, you can just ask. Okay, let's continue then. So let's move on to, now let's understand why do we need Kubernetes. So till now we have understood what are the meaning of containers and Docker, as I've just told, that Docker is basically helps us to build containers, and Kubernetes sits on top of Docker. So Kubernetes uses Docker to manage containers. It's like that. So why do we need Kubernetes as such? What was the need for creating such a famous tool, first of all? So for that, let's understand a situation. So in this figure, you can see there are 3 boxes, okay, and each of this has a host. So by host, just consider host to be your computer. So suppose you have 3 computers. On these 3 computers, in each of these computers, you have 4 containers running. Okay, so you have 3 computers, and in each of these 3 computers you have 4 containers running, and together all these 12 containers are connected together. Okay, they're connected together, and once they're connected together, you are able to see your application. So basically what you did was that you had a web application with you. You divided that application into 12 containers. Okay, and you placed 4 containers in each of your 3 computers. So now the containers can interact between themselves, and so your website is properly running. But suppose, let's think of a situation when this container stops functioning. Okay, this container has stopped functioning. Then what will you do? The first option will be like, go and just go and just check which container is not working, and then basically restart that container or solve whatever problem it's facing. Okay, but think of a situation where your application doesn't have only 12 containers, but it has more than 100 containers. Like, consider an application like Amazon. So Amazon, you can't just tell that Amazon has only 12 containers. They must have at least 100 containers, because they have so much big code and their code are broken into various parts. So of course they must have a lot of containers. So it's not manually possible for us to go and check always if every container is running properly or not. Suppose this container fails and I am not in my office right now. How will I get to know? Because if this container fails, and suppose this container is important and this container is responsible for the payment service. So suppose this container is not running when I am out of office, then my entire payment service of my application blocks. No one can pay. It's a disaster, you know. So you need some tool that can automatically manage all the containers on its own. You just have to tell them that these are my containers, you have to manage them. You have to see that whatever happens to the container, my application should not have any problem. If you find the container not working, change it, restart it, do whatever you want, but my application should always run. So you need someone for that, and that someone is Kubernetes. So Kubernetes is a tool that will help us manage all the containers in our infrastructure. So suppose a container is not working properly, Kubernetes will instantly come to know and then try to restart it and see whether it's working or not. If it doesn't work even then it will just destroy this container and launch another container of the same type. Okay, so all these things, like suppose you have more traffic in your website that you have not imagined, but you have Kubernetes activated. So Kubernetes will automatically launch some more containers similar to this, so that the traffic get balanced, your website doesn't get crashed. Okay, so this kind of automation, so this kind of management or orchestration, the word, just focus on this word, orchestration, is very important. That's why Kubernetes is known as a container orchestration tool. Orchestration means properly orchestrating, properly managing all the containers in your infrastructure. So I think you have got an idea of why do we need Kubernetes right now. If you have any questions, you may ask. Okay, moving on. This is basically a statistics. From this you can see, like, among all the different container orchestration tools available, or other tools also available, Kubernetes has been adopted by 69% of the organizations who use containers. Okay, so it's a very big number, and it has become a de facto orchestration platform. That means it has become the most common one, that whenever you want to use any orchestration tool, the first name that will come to your mind is Kubernetes. Now there are the various reasons for that. First of all, it's made by Google, or it was open sourced by Google in 2014, and it's maintained, and since it is open source, anyone can just see the source code, change them and use for their own purpose, and thus it's more easily accessible and more adaptable for other companies who want to build applications on top of Kubernetes. Okay, So that's why it got very much famous. And now it's the market leader in the container orchestration area. Okay. So that was it about Kubernetes. So the basic idea I'm able to share with you. I'm not going in depth in Kubernetes because that's out of scope of this session, and it doesn't matter as a developer to know everything of Kubernetes. Just focus, you're a developer. Your main goal is to develop your applications and just try to deploy them in any place so that everyone can see. Okay. So next we come, what do you mean by continuous integration? So continuous integration, that was the topic in our agenda today. So what do you mean by that? So let's first understand, read the definition that's available in the internet. So continuous integration is a software development strategy that increases the speed of development while ensuring the quality of code that teams deploy. Okay. So basically, just remember, it's a software development strategy. Okay. It's nothing very difficult to understand. It's like a strategy that teams follow so that they can deliver more good quality code and also deliver the code very fast. Okay. Now, there are various, since it's just a strategy, there can be various use cases of this continuous integration. Suppose one of the use cases may be you have actually you have an application on GitHub. Now you have changed some of the code in that application, and you have pushed that application, pushed the changed code into GitHub again. So now once you push or commit the changes, some automation steps will run. Okay. So one of the automation steps may be the code that you have pushed will be tested whether there is any security issues or not. Then another test may be, is it properly linted or not? So all this test will happen automatically. So your action is to just push your code as a developer, and some steps will automatically perform after your push. And after, if each of these steps run, only then the things will move on. Okay. So this kind of automations or continuous integrations is possible via the help of continuous integration. Okay. So basically continuous integration, for simple words you may understand, like of some steps that will be followed in an automated way whenever there is a code push or any change happening in the repository. Okay. So I have told you about one use case. The another use case that we are going to see in this session is we are going to deploy our application, that is a simple Node.js application, on top of Kubernetes with the help of this automation pipeline. So at last we will see that a developer will just push or change a small bit of code in the repository, and automatically a pipeline will run that will deploy that changed application back into Kubernetes. So a developer does not have to go and check whether the Kubernetes is running with this current application or not. This will happen automatically. So this kind of automation pipelines we will be creating using this continuous integration. So let's come on to the next slide. So technology platforms which we are going to use this time are two platforms. Basically, we are going to use Microsoft Azure Kubernetes Service. That is basically a managed Kubernetes service provided by Microsoft Azure. And the second thing, we are going to use the Circle CI for our CI tool or the continuous integration tool. Okay. So as I have just mailed you today morning, so if you did not have any Azure account, you could just use the GitHub Developer Students Pack to get a $100 credit. And also Circle CI is free, so it doesn't cost you any money. So these two tools basically we are going to use to set up the automation we are wanting. That is, whenever a developer pushes any code in the GitHub, automatically that change will reflect in the application that is running inside the Kubernetes cluster. Okay, so that's it basically for the theory. So let's move on to the hands-on part. So this is basically the repository that I have made. So this repository contains the boilerplate code or the Node.js application. So we are not going to make the Node.js application currently. It's just a hello world application. But what we are going to do is that we are going to deploy this on Kubernetes. Okay. So just take a 5 minutes break, or let's take a 2 minutes break, so that you can also set up your environments, so that we can start off with the hands-on. Okay. Okay. So I think you are all set. If you have any questions, you may ask. Any questions?
Um, it takes 7 days to verify the GitHub profile. I mean,
Okay, I got it. I got it. I got it. Yeah, that campus, that program, that students develop a pack program. It takes time for, yeah, it takes time for properly authentication. But no problem. Just see what we are doing, because obviously this session is being recorded. So yeah, you will get it. Okay, no problem. So let me just let's start with our work then. Yeah. So just a second. And has everyone just copied or noted the GitHub URL that I have shared? Because that is basically the boilerplate code, and whatever code that we are going to write here will be committed to that repository itself. Okay. So if you have not, just note it down.
can you share it once again?
Yeah, I'm just, can you see the chat? I know you can't type, but can you see the chat?
No. Chat in meeting is only available to team members.
Okay, 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 no problem. I'm sharing it. Just a second. Okay, so let me just open the browser and share that itself. That will be great. So basically, let me share my screen now. Everything's set. Yeah, is my screen visible?
Yeah.
Yeah. So basically, this is the GitHub URL. So you can just type it if you want. You can see. It's basically github.com/lucifergene/aks -ci-deploy. Okay, that's it. Okay, so I think it's done. So now let's move on. Let's first see what is there in this repository, what I have already committed. So basically this repository contains simple thing. If you have worked with Node.js, you must have known that for an application like Node.js, you need to have two files. One is the app.js, another is the package.json. Okay, this is the two things you want. Just a second. Yeah, so is it visible? Okay. Okay, so basically, if you have worked on in a Node.js, if I have worked on a Node.js application in your first year or in your second year, then you must be knowing that for any Node.js application to run, you need a app.js file and a package.json file. Okay, so in the app.js file, you have the logic for the server, while in the package.json file, you have the packages that is required to run that application. Okay, it's simple. And to run an application of Node.js, first of all, you have to run this command npm install. So by running this command, all the packages written down in this package.json file will be installed. And after that, to run the application, you just have to type node app.js, since my file name is app.js. Okay, so with these two commands, you can just run your application locally in your system. Okay, but what are we trying to achieve? We are trying to achieve is that we are going to deploy this Node.js Hello World application on top of Kubernetes. Okay, on top of Kubernetes, we are going to deploy it. So we don't want to type like this anywhere in our computers. I want everything to be automated. So how will we do that? So first of all, to start with, let's open our Circle CI. So let me just close all this. Go back first of all. So let me just yeah. So I think what you can do is that if you have Circle CI, basically you have Circle. If you have signed up for Circle CI, and after you have connected your Circle CI account with the GitHub account, you will see all your GitHub repositories being listed down here. Okay, so once you connect your Circle CI with your GitHub account, you can see all your GitHub repositories listed down here. So what you can do is that after, first of all, what you need to do, you need to fork this repo. Okay, just click on this button, that will help you fork this repo. So what do you mean by forking? It means a same copy of this repo will be created in your own account. Okay, you don't have to copy and paste anything. If you just fork it, automatically this repository will be created in your own account. Okay, so once you fork it, you will be able to see the name of the repository here. Okay, in this projects list. So once you see that, just click on setup project. Okay, now I want to click here, this one, commit a starter CI pipeline to a new branch. Okay, and then click setup project. So what it will do is that it will put a hello world pipeline in a separate branch in our code. So how can we see that? You can see a hello world job has been set up by Circle CI in a separate branch. So we need to also see that, no? So how can we do that? By like this. Okay, so just a second. Yeah, so this was our repository. So in this repository, this is our main branch. Okay, so if you are new to Git, just understand that the concept of branches. So basically in a single repository, you may have multiple branches, and each of this branch the code may differ. Okay, so this is the main branch. In this main branch, we have our boilerplate code. So I'm not going to push anything in this main branch. Okay, so what I did was that automatically Circle CI created a new branch. Let me just refresh it. Then you can see automatically Circle CI has created a new branch in my repository. So I will click on that new branch. Okay, so once you open the new branch, you can see a new folder coming up, Circle CI. So this was not there in the main branch, as you have noticed. This is there only in the Circle CI branch, and this branch has been created by the Circle CI itself. Now, whatever changes we are going to do from here on, you are not going to use any local editors or anything. Okay, so I am going to do everything, like all writing of code to everything from this browser itself. I want to show you the power of GitHub nowadays. So once you just open your repository, in your keyboard, just press the full stop key, like the greater than symbol and the full stop key that you see on your keyboard. That is next after the less than symbol. Just click on that. Have you understood which key am I talking about? Like you have the M key, after the M key you have a less than key, and after that less than key you have a greater than key. That also has a full stop.
It opens VS Code online.
Exactly.
Yeah.
So just press that full stop key. Okay, once you press that, you will see automatically a VS Code environment launches inside your browser. Okay, that's it. Now whatever we are going to do from this VS Code environment itself. We are not going to set up anything in our local system, nothing else. Okay, now let me show you what are the things required to build the pipeline that we are wanting to do. Okay, so first of all, you can see here that we are in the Circle CI branch. I'm not in the main branch, I'm in the Circle CI branch. Check that first of all. After checking this, then let's understand what we are trying to achieve. So as I've told you, we have to deploy this application on Kubernetes, and Kubernetes deploys containers. So we have to actually make a container of our application. That means we currently have only our application. We don't have any container. So we have to build our own container first. So how will we do that? So we will do that.
Do we have to make a YAML file?
Yeah, I'm coming. Just wait. Let me just explain everyone. So I'm coming. I will come back to you. Okay. So the thing was that what I was saying was that you have to first of all, the first step is we have to make a container of this application. Okay, because when you're trying to deploy anything on Kubernetes, you have to deploy as a container. You just can't put this app.js and package.json directly in a Kubernetes. Okay, so the first step is making a container. Now the question may arise, how will you make that container? So for that, someone that asked sometime previously, like we have a tool known as Docker. So with Docker, we are going to build our container. So Docker is a tool that will help us to build the container. But now the next question arises, how will Docker come to know which are the settings we want in our application or in our container? So for that, we have to actually provide some information to Docker. Tell the Docker that, Docker, please make the container following these instructions. So we have to write an instruction file, and that file is basically what you just said. It's a YML file. So the name of that file has to be same always. So the name of the file should be Docker file. Okay, simple. It's for Docker, so the name should be Docker file. Okay, once you just write this Docker file, automatically the symbol will change to Docker. From that you can verify. So right now you have created a Docker file. Now you have to write what are the steps you need to create your own container. That Docker should follow to create the container. So the first step that you want is that since your application is running Node.js, So you want, first of all, Node.js being installed in the container. So how will you do that? How will you tell Docker that thing? So you will write from node 16. That means I'm telling Docker that Docker, please first of all bring out a base image or a container that has been already been installed with Node.js. Okay. So I'm telling Docker, please download a container that already has Node.js installed in it, and it has a 16 version of Node.js. Okay. So now Docker has brought me a container that already has Node.js in it installed. So now what I want to do, I will create a new folder. I will name that folder app. Okay, just for properly arranging our code, we need to create a folder. So now we have created the folder. The next thing what we need to do is that we have to, as I've told you, when you are running a Node.js application, first of all, you have to install all the packages required to run that application. And where are the packages written down? It's written down in this package.json file. So we have to bring that package.json file into this Docker container. So how will you do that? Simple. You just write copy package.json into this container. So this full stop means here in this folder here. So copy the package.json from the repository into this container what you are building right now. Okay. So once package.json has been copied, so now I want to run the command npm install. I will write run npm. That's it. So that command is also done. So after that, what I will write, after my packages are installed, now I want to copy all the other files like the app.js and everything. I want to copy back into my container. So for that, how will I write? Same thing, copy dot and dot. So first dot means copy everything in this repository, and the second dot means paste it in this app folder. So copy everything from here, paste it in this folder. So now in this container, we have everything. Okay. Also, we have installed a package, and also we have Node installed. So now nobody can stop us from running the application. So what is the next step? We have to tell which port our application is running. So if you just check this app.js file, you may see that it's running on port 1337. Okay. So you will see a hello world application running in the port 1337. So what will I do here? So in Docker file, I have to mention that expose port 1337. That's it. After that, I will write the final command that is required to start my Node's application. That is node.js. Simple. Just 1, 2, 3, 4, 5, 6, 7. In 7 lines of code, you are actually telling Docker how to build the container of your choice. Okay. So once you do that, once you complete this, just click here. You can see that there is a change made to this Docker file. So let's commit it. I will write added Docker file. Okay. And I will just push it to my Docker Hub. Okay. I'll just push it to my Docker Hub. To my GitHub, I mean. Sorry, it's to my GitHub. So now my Git code should have a Docker file also present there. So first step is done. Now my Docker can make the container what I want to make. Okay. So the next thing what I want to do is that I have to also write the settings that will tell Kubernetes what to deploy in it. Like, first of all, when you're working with Kubernetes is also a program, no? So you have to also tell it to actually follow some rules so that the application that you want to get deployed on Kubernetes. Okay. So for that also you need to write some files. Okay. But as in case of Docker, you have to write a single file, but in case of Kubernetes, we have to write a little 3 files basically. We have to write 3 files because, as I have told you, Kubernetes is a vast thing. So we need to put some more information or some more settings. We have to set some more settings for the Kubernetes to actually deploy our application properly in our space where we want it to be. Okay, so for that, for the settings for Kubernetes, I'm going to make a folder and name it manifests. Okay, so I'm creating a folder named manifests. So I've created that folder. Now inside this folder, I will create some more files. One is deployment.yml. Another file I want to create, that is service.yml. Another file I want to create, that is customization.yml. Just 3 files I have to write. So what will be in my deployment file? I'm just copying it. Later on, I'm going to explain you what I'm writing. So this is basically a Yml syntax. So what do you mean by Yml? So basically, it's a declarative type of language. Like normally you have worked with C, C++, Python, Java. So those are imperative languages. That means for those languages, we have to actually tell what to do and how to do. Suppose in Java, you want to basically find the square root of a number. So you have to tell Java what to do. That means whose square root you have to find out, and also tell them how to find that square root. You have to put your own logic. That is an imperative type of language. But when you are working with declarative type of language like YAML, you don't have to actually write how to do it. Just have to tell them what to do. They already know how to do that. So here in deployment file, I'm telling it that make a container name of node CI, take the image node CI, expose the port 1337, make a 3 replica. I'm just giving him instructions. I'm not telling how to basically execute these things. Okay, so Kubernetes already knows all these things. So it just needs some settings or declarations that he wants to perform. So he needs something declarations that he knows that by performing this kind of settings, my application will be launched. Okay, so this was the deployment file. Moving on to the service file again, let me copy it. Basically, most of these Kubernetes settings are mostly boilerplates. That means you will see same code written multiple times. Only a small part gets changed. So here also you can see everything is remained same. Only what I change is that the port that I want my application to run on, that is 1337, and I want to expose it to port 8080. And I'm using a balancer I'm using a type that is load balancer. So I don't want to go in depth what is load balancer, but in one line I'm going to tell you, since I've used load balancer as my service type in Kubernetes, that's why I will be able to see my website from my browser. If I had placed something else like cluster IP or node port, I wouldn't have able to see it from my browser. Okay, that's it. Basically, this load balancer will give me a public URL, and through that public URL, I will be able to access my website. Okay, simple. That's it. Moving on to the next file, that is the customization file. So in this file, basically, again, a simple thing. So in this file, basically, again, same thing. Here, basically, customization file is a special file. This file is required because we need to actually change continuously the tag of Docker. Okay, so I will come back to later. Why do we want to change the tag of Docker? But for now, understand this customization file is very important because it will, if I execute this file, this will generate both of my deployment and services based on the condition I provided here. So you can see in my deployment currently, I have not provided a tag of this container. So in Docker, if you just see, for example, if you just search node, like the image that I had used previously in my Docker file, node image. This node image is maintained by Docker in Docker as well as the Node.js team. So you may see here, there are various images of Docker of Node.js available, and each of these images had some tags, okay, some tag attached to it, and these tags are different, okay. So in a similar way, I also want all my containers to have different tags, okay. So for that, I need to constantly update my tag. So this file will help me to constantly place a new tag inside this deployment file. So it will generate another deployment file automatically once I execute this small file. Okay, it's a little complex, but once you understand, it will be great. Basically, for simple words, I'm telling you, like, this is basically a master file. So through this file, I can generate the deployment and service according to the settings I am providing it here. Okay, in simple words. That's it. Basically, these three files were needed. After that, what you need to do is that just comment this back. So how will you comment it? Just write added manifests. Just comment it. Done. So now in your repository, you have your Docker file as well as a manifest file to run your application on Kubernetes. So the last thing that is left is that we have to write the pipe or the pipeline for our continuous integration. So this is the most important thing. Okay. So you can see I was pushing the code, like this was the added Docker file, added manifest. Automatically, they were actually trying to execute this job, the say hello job. So from here, you can understand that whenever I push something into my code base, automatically this circle CI will trigger the jobs. Okay. So I don't want to say hello world in this job. What I want is that whenever I will push something in the code, automatically this job will help me to deploy that code into Kubernetes. This level of automation we are trying to achieve. So how will we do that? So for that, again, we have to edit the deployment or the config file of this one also. So how will we do that? Just have to go, just select this one, the basically the project you want to change the config file, select here and select configuration file. So on selecting that, you will be loaded with an editor in which the configuration file is present. So the current file that is present is only saying hello world. Okay, as I have shown you there, it's just showing hello world. But I don't want this. I want something more complex. Okay, so what I'm going to do is that I'm going to delete everything. First of all, delete everything, and again paste the thing that I want in this first. So this is basically the code. It's a long code, but don't worry. I'm going to explain this in a very easy manner. Okay, don't worry at all. So first of all, let's start from the end. Okay. So end, you can see, first of all, let's understand some basic idea of the basic terminologies basically of Circle CI or any other CI tools. It may be Jenkins, it may be GitHub Actions, it may be Travis CI, anything. So when you're working with CI tools, mostly you are trying to make some pipeline. Okay, some pipelines are basically set of jobs that will automatically get triggered either together, like parallelly, or one after the other. So these pipelines are known as workflows. Okay, so here what I want is that I am creating a workflow with the name deploy app on AKS. So I'm creating a workflow of type deploy app on AKS. So just a reminder, so when I'm working on this file, I have to have a AKS cluster running also. So for that, an AKS cluster takes a little bit time to launch. So let's create the AKS cluster before continuing here. So for that, just go to your Azure account. You will come to this page. From here, I want a Kubernetes service. So type here just Kubernetes service. Okay, it will come up here. Click on that. So what is this? What we are trying to do? We are trying to actually rent the Kubernetes that is managed by Azure for some time to basically do our work. And during that time, whatever Azure will ask us to pay, we have to pay that. But you don't have to worry. If you go by the GitHub Student Developer Pack, you will have $100 of credit, and that will be enough to understand how to work on Kubernetes. Okay. So moving on, I want to create a Kubernetes cluster, or I want to rent the Kubernetes service of Azure for some time. So I will click here. I will click create. Just wait for some time. Let it load. Yeah. So now I have to put the settings. So I need there is a concept of resource group. That means it's like a folder, like whatever things I want to create right now, I want to place it together in a folder so that I can delete that folder after the work is done. Okay. So let me just name that folder AKS. Yes.
What does cluster mean here?
Yeah.
What does cluster mean here?
Cluster.
Yeah.
Yeah, basically what I have just shown in the figure in the PPT, like you have seen that Kubernetes is sitting on top of 3 nodes or 3 computers. So like you have the first computer in which 4 containers were running, second containers or 4 containers were running. You remember that? So
yeah.
Just think there are more hundreds of containers, hundreds of computers, and on top of that 100 of containers are running. So it gives a feeling of a cluster. Okay. It gives a feeling of a cluster. So that's why it's known as a cluster. Okay. So Kubernetes cluster means basically a Kubernetes is made up of 2 things. One is a master node and and others are worker nodes. Okay. So I don't want to go in depth in the architecture Kubernetes, but if you want to know, just for a small understanding, the meaning of cluster. So Kubernetes is made up of a master node and some worker nodes. Okay. So if you have studied about something known as master slave architecture, it's like that. So the master node or the control node gives the instructions to the worker nodes, and the worker nodes performs the functions accordingly. So mostly we will be seeing that a single master node controls at least 10 to 12 worker nodes, or there may be a case that 2 master nodes controlling 4 worker nodes. So this kind of architecture, it gives a feeling of a cluster. If you see a proper diagram of a very densely populated Kubernetes, you will see it looks like a cluster. So we name it a Kubernetes cluster. Okay, nothing more than that. It basically makes us understand what is Kubernetes more easily. It's basically a cluster. It forms a cluster of containers. You can understand like that. Okay. Otherwise, nothing more than that. Basically, cluster. Just visualize. It helps in visualizing what Kubernetes is trying to form. It's like visualize. Like if I just say the word cluster to you, you can understand like something like Kubernetes. Okay. Moving on. Setting some of the things, putting very low cost things here. Again, making it AKS only, the name. Then what I am going to do, it is optimals. Then I'm going to make it 1. I want to make it as lower cost as possible. Okay. So that you can, if you are following this, you don't charge a lot in your account. Apart from this, I will go to networking tab and just select this one. Enable HTTP application routing. And after that, I will go here. Just wait for some time. It will just validate whether all my settings are proper or not. Yes, it has validated. So I will just click. I have named it AKS, no worries. So create. Okay. So now this will take some time. Okay, this will take some time. Kubernetes, as I have told you, has master node and worker nodes. Each node means another computer. So to set up everything, you need some time. You have to give some time. So till Kubernetes is launched, let's continue with the pipeline. Okay. So as I was explaining you, so this pipeline basically contains 3. First of all, I was explaining you the terms. So first of all, workflows means the pipeline. That means what are the entire pipeline or the set of jobs that we are going to perform whenever there is a change in the GitHub. That is known as a workflow. Okay, the set of jobs. So the name of the workflow I have given, deploy app on AKS. And this workflow contains 3 jobs or 3 tasks. So all these 3 tasks will be performed. Okay, whenever there is a change in the Git code. Okay. So what are these 3 jobs? The first job is Docker publish. So this is actually the job responsible for executing the Docker file. So as I've told you, as you can see, we have this Docker file created, and I have told you we have to execute this file so that Docker gets to know what is the settings required. So we don't want to execute it manually. So what we are going to do is that we are using this job. So this job in turn is going to execute that Docker file automatically whenever there is a code push. Okay. So the next job that is there is the bump Docker tag customize. So what this job is doing is that this job is actually changing the Docker tag, like I've just shown you, the customize this new tag. So new tag, I told you this new tag has to be always been changed. So this change is taking place with the help of this job. So why do we need to change this? So in simple terms, I'm telling you, like when we are going to push something to Docker Hub, then the image that we are pushing, we are also tagging it with a random value. So we need that random value also gets saved in this file so that the Kubernetes gets to know which container needs to be pulled. Otherwise, since I'm tagging it the random value always, so Kubernetes will not know which container to pull. So what we have to do after tagging the container after pushing it to Docker Hub, we have to save that tag or use that tag or basically commit that tag back into this customized file so that when this customized file gets executed, my deployment and service file will be created with this new tag, because with this new tag only Kubernetes will understand the new file, the new code that has been pushed. Otherwise, if you don't do that, your new code won't be pushed. The same, you will see the same website always. Okay, so for that I need this job, and you can see something written here, requires Docker publish. That means before this job to run, I need to run this job. So basically the concept is that mostly jobs run in parallel. That means all these 3 jobs will be running together. But I don't want that. I want after this job runs, only then this job runs. So for that, if I just write requires the name of the previous job, this will take a serial approach. Like after this, only then this will continue. So you understand this part? So after that, the third job or the final job that we are doing is that now we have made the Docker container, we have pushed to Docker Hub. Also, we have changed the Docker tag. So now we need to just deploy that Docker container into Kubernetes. So we have another job that is a case deploy. So this deploy is taking the cluster name and the resource group, and it is also telling that only after this succeeds, only then run this job. Okay, that's it. So these are the 3 jobs that we have to perform to actually deploy our code, changed code in the Kubernetes when we change anything in our app.js file. Okay, that's it basically. So on top of this, what you are seeing is just this is basically, you can call it this to be a function, and I am just calling the function here, but the actual function definition I have defined it up previously here. Okay, so this function definition is a little bit longer, and since we have a little very less time left, I don't want to again go into this definition. But if you just see, it's very easy to understand, or if it's difficult to understand, then it can be basically these are things should be abstracted. Okay, so the most important thing is to understand how you write these jobs, while the function names can be abstracted for now, and you can easily understand by just going through the commands. Okay, it's not that difficult. So moving on, basically this is the job I wanted to set up. And one more thing I want to tell is that here you are seeing that a lot of dollar signs given, like dollar docker login, dollar circle shas, dollar cluster name. So what are these? So these are basically variables. Okay, so in the cluster name, I'm not passing the cluster name directly. What I am doing is that I'm creating a variable, and I am basically placing that variable here. and I'm defining this variable or putting the value in this variable in somewhere else. Okay, so like that, I don't want to expose my passwords and everything in the common, because this is going to be pushed into GitHub. No, so you should not place all your secret or information directly in this file. You should create environment variables and place these variables in a separate area. So how will you create that? Let me just show you that also. So for that, just duplicate this and select go back. Now what you want to do, select this project settings, go to environment variables, click add variable. Now see, cluster name, I'll just copy this name, cluster name here. The variable name is cluster name. And what is the cluster name I gave? Say it has been launched. Okay, my AKS also has launched. So my cluster name is AKS itself. So I'll copy this, come here, paste this here. Okay, so cluster name is placed. So I've added this one. Okay, so like this, I have to actually add all the basically variables that I have placed here into this environment variables, so that I don't expose all these variables in the GitHub. So this remains secure in Circle's environment itself, and I don't push all these settings or passwords into my GitHub directly. Okay, that was the thing. So give me 2 minutes. Let me just type all those passwords, all written to be required to run this application, and I will just share my screen after that. Okay, give me 2 minutes. Till now, if you have any questions, you may ask. Am I audible?
Yes, we are.
Any questions? If you have any questions, you may ask. Just a second. There are lots of basically passwords and everything you have to set, because you are doing committing, you are pushing it to Docker Hub, you are pushing it to Kubernetes. A lot of passwords required. Your Azure password, your Circle CI password, your GitHub password, all those things are required. So it takes little time to set everything. Yeah, okay. So I think I've set everything, all the passwords. Let me just share my screen once. Yeah, is my screen visible? Is my screen visible?
Yep.
Okay. So I've typed all those passwords and everything.
Is the tag randomly generated?
Yeah.
Is the tag randomly generated?
Yes, yes. So basically, what is happening is that there is a random value that can be called, that is circle SHA1. So basically, SHA basically is a hashing technique. Okay. So what is happening is that whenever you're committing something, you get a commit number, and then this commit number gets hashed with the SHA algorithm, and you get another random number. So the random number that Circle CI gives us in our as an environment variable. So I am using that environment variable everywhere. So what I'm trying to do is that, since I know that my Docker tag should be different, but I also know that if I change my Docker tag, I need the same tag to be also pushed or in the customization file. Without that same tag, my Kubernetes will not understand that there is a code change. Okay, so I need to follow both these conditions. So for that, what I did was that, first of all, I used that random tag, and then I committed that random tag back into the code base. Okay, so the random tag gets again copied and base updated in the code base here. So right now what happens is that whenever you push something, a Docker container gets created, that tag, Docker tag, gets also updated in the code itself. So right now the Kubernetes will understand that there is a change in the Docker tag number, so it will understand that I have to again deploy a new version of that. So if you did not do that, then Kubernetes will not understand that there is a difference, because again, if you go inside Kubernetes, you will understand there is a concept of control loops. That means the Kubernetes always checks what is the current state and what is the desired state. So, and how does it check? Basically via these deployment files. So if they see the both of the deployment files are same, the current one and also the thing it has already, nothing will happen. It will not update. So I need to specifically change this customization file so that Kubernetes get to know that yes, there is a change in the Docker file, that Docker container. That means you need to update the container in your Kubernetes cluster. Okay, got it. That's why we're using this tag.
Okay.
So this tag concept is again this is advanced stuff, because it's not available. As you can see, I had to define this function. Okay, this was not available. It's not available anywhere. I have to define my entire function, what I want to do. That's why I tell, like, suppose I have to make a job. Some of the jobs are available already by Circle CI, you can find some of the plugins available. Like this is a Docker plugin already available. From if you just call this plugin, automatically you just have to pass image and tag, it will be pushed. But all this type AKS deployment and bumping Docker tag, there is no plugin available. You have to define that on your own. Okay, that's what I have did. So let's we have done that. So let's just try to run it and see whether it happens or not. Save and run, commit. Let me see, I have committed all this. Yes, it's all committed. So I think it's your fingers crossed. Let's see if it happens or not. So let me Docker publish. Let's go to that page. Let's see the steps that are going. First job that I've told you is Docker publish job. So let's see what are the things it is happening. So first of all, what it is doing is that it is spinning up an environment, then preparing the environment variables that I just pasted, then logging into Docker with my username and password that I entered in that environment variable section, and then it is building this Docker container. So how is it building this? With the Docker file that I had mentioned. So this pipeline or this plugin is actually executing this Docker file that I had written. I'm not executing it manually. It is being done automatically. Okay, that's the thing. And after that, it will push it to Docker Hub. Let it push. Yes, it has pushed. How will I see that? Let me open my Docker Hub account. In profile, I will just go to profile. I will see here. Can you see? Node CI. So updated a few seconds ago. So automatically, I just committed that stuff. Automatically, the container got built and got pushed to Docker Hub without any execution from my side. It got automatically executed. See, this is the random text, random tag, and this is latest tag. This tag I was passing by that circle SHA command. Okay. So let's go back and see if anything other failed or passed. Yes, this one also passed. So this is a cool representation. Like first of all, Docker publish the job is going, then it is the bumping of Docker tag, and then is a deployment job on a case. So let's see this bumping Docker tag once, what's happening behind it. So again, same thing, installing, customize and all those things. And it is after changing that thing, it is pushing back to GitHub. Like after changing this, like after changing this new tag to the exactly the tag that this one. So this tag is same as this tag. So after changing that, it is pushing to back into the GitHub repository. Okay, that's it. So this job is also perfect. So next job, the final job was deployed on AKS. So here also same thing, installing kubectl and all those things. And finally, they have updated the resources. That means you can see service and deployment that I created here in the manifest file, service and deployment files. So these got automatically executed. I did not go and execute these files. They went automatically executed by the job that I created. Okay. So right now, if you ask me, the application should be live in the Kubernetes cluster. Now, how will I check that? Again, I will go to my Microsoft Azure portal. Here, what I will do, I will use the Cloud Bash shell itself. Okay. So my Azure itself provides me with a Bash shell to test something, like rather than installing the CLIs and everything in my own computer. Let me use that itself. So how will I connect to that? Just click on this connect button. You will be getting these two options. Copy them and just paste it here once it is available. Yeah, it's available right now. I'm pasting it here. Pasted. Second one taken. Pasted. So now this thing is can communicate with this cluster. Okay. So what I am trying to do right now, I am trying to fetch the IP address. Okay. Since I want to see my website, so I need the IP address. No. So I want to fetch that IP address. So how will I fetch that? Simple. I will take again the command that has been written here. Paste it. Enter. Let me see whether my Node.js is available or not. Yes, you are seeing here default Node.js. So my Node.js application that I just pushed has been deployed on Kubernetes. Now I want to see the IP address. So for that, I will just, in the previous command itself, what I will do, I will just go and change it to service. Okay, instead of deployment, I will change to service and press enter. And let's see what we see here. And can you see this one? We have Node.js pod running with a type load balancer that we had set before. This is the private IP and this is the public IP. So I will copy this and try to launch it and see whether my application is running or not. And you can see here very properly written hello world. So this was exactly what I had written here previously, not here, this one. I written here previously hello world. That is, you can see in this website also. So this is the thing that I wanted to show. Now one more thing, the final part, the most important part that we all want to see. Like now I will be just changing this hello world to something else, and let's see whether any other interaction, I will just change this hello world to something else and I will just commit it, and let's see whether it automatically changes here or not. Okay, let's see whether it happens or not. So let's change it to something like welcome to case CI workshop. Done. I've changed the response, so this should be printed here if all goes well. Okay, so now I've changed it. So what I have to do, commit it, made a small change, and then let's hope for the best and commit it. Okay, so here you see there is some issues, like some you have to sync first. That means since this Docker tag had been updated, so I did not pull it. So I need to pull, then push. So I will just click this button, sync. So it will first pull it, then push my change. Okay, so it has pulled first and then it has pushed it. So now let's see what happens. Let's go to my Circle CI and let's see what happens. You can see right now, automatically jobs have started. I just pushed and automatically jobs have started. Now what's happening in this job? Let's see that also. Same, these 3 jobs will run. So again, let's wait for some time. Let these 3 jobs get performed well. And after that, we will open the website and see whether it has changed or not. So have you, so in the final part, I wanted to ask, like, was the session helpful? Was the session interesting to all of you?
Yeah, sure. I learned a lot of new things.
Yeah.
I learned a lot of new things.
Yeah. Anyone else who want to just come up and just speak something? Currently,
Look, the workshop was quite helpful as I was trying to deploy my own site. So this is quite helpful for me. And can I ask for the recording, as
yeah,
so
sure, sure.
things are going on and I cannot properly catch up.
Of course. I know
Thank
this recording, I have started recording. No, that's why. So
you.
it will be, I will upload this by this weekend on the Mozilla website, Mozilla YouTube channel. Okay. So Mozilla BBSR has the YouTube channel. I will upload there also. And also, if you want, I can share the link of that basically recording once you just submit from you basically when I will be sending that participant certificate. Okay. So from during the participant certificate also I will update that. I will include the YouTube link. Okay. So you can
And
see here. Yeah,
one more thing, if I get stuck somewhere, can I contact you for?
of course, of course.
Okay, thank you so
Not to
much.
mention, of course. I have introduced you to this, so it's my responsibility that you succeed. Okay. Otherwise, suppose I leave you right now, it's obviously that you will be get stuck in somewhere. You will get stuck somewhere. Okay. So it's my responsibility to solve all your queries right now. Okay, so you can see here these 3 jobs are perfect, has been completed perfectly fine. So let's hope for the best and see whether it has updated or not. Yes, can you see it has updated? So finally what we were trying to achieve, like we will change something in this code base, or here basically we'll change something in this code base and automatically things will get updated in the Kubernetes cluster application without our involvement in any Kubernetes commands or anything else. So as a developer, your job is just to push your code into GitHub, and automatically your application will be deployed on Kubernetes without any manual work done. But for that, for a one-time work, you have to set up the things that I had just told you. First of all, you have to set up this Docker file, a manifest file, and a proper CI/CD configuration. So once you set up all these configurations and everything, then you are good to go. You don't have to bother at all of all your deployment stuff. Whenever you will push something, it will directly deploy it on Kubernetes. Okay, so yeah, that was it. I showed you the final demo also that went successfully. I did not expect that to be happening in the first time itself, but it happened. It's good. But yeah, that was it basically. That was my plan, and I have delivered everything. So if you have any questions or any more suggestions, you may ask. We have more 3 minutes. After that, we will close this. So anything if you want to ask, you can just speak out. Was it, first of all, just tell me how many of you were trying to do it right now?
I was there. I was doing it.
Okay, fine. Anyone else? Okay, that's good. And how much did you proceed with?
I basically connected my AKS, I mean the Azure cluster with the CI.
Okay, that's great. As the first time you are learning something and you have done it something, that's really great. Okay, so I don't, any more questions or we may end this? Oh, before ending, I'm sorry to just forgot. Before ending, just I want to share my screen once more. Just a second. Yeah. So we have completed all this. I'm done. Yeah. So I just request all of you to actually fill up this feedback form, because on the basis of that I will be sending those certificates and all those things. So just you can just scan this QR or just type this URL and just fill the feedback form. And once you have done it, you can just leave. Okay, thanks a lot. Or if anyone has any questions, you may ask also.
Hello, can you conduct a workshop on React and all those React and Node.js?
See, thing is that I am actually not a proper or a high advanced web developer. Okay, so I know I have worked with React, and my current work also I have some bits of React, but the thing what you are wanting, I cannot deliver that, because that requires some proper experience in React. But I have spent most of my time in understanding all these kind of technologies. So don't worry about that. I will, if you can just ping me. I will just connect you with some good developers in React with whom you can just get some ideas. Okay.
And Bhaiya, just I add to that. If we see that
a lot of people are interested in React, then from Mozilla's side, we'll conduct more events on React and
Yes, definitely.
other
Of
technologies.
course, that's always there. Yeah. Okay, so I think everyone has completed filling up that form, and it's already 7:45. So then, good night, guys. Okay, goodbye.
Good
Okay,
India.
thank you.
Thank you, Bear, for this amazing session.
Thanks a lot.